Okay, today we're going to work on the second part of materials, which for us is going to be transparency, transmission, and refraction, basically making glass for the most part. Glass is not difficult to make, but there are several steps involved, and there is a little bit of troubleshooting occasionally that you have to do. Now, whether you work in mental ray, whether you work in Maya, whether you work in Arnold, whether you work in V-ray, glass, for the most part, is going to be the same process. You need to know something called the index of refraction. That is what describes the material in transparency and refractive terms, or transmission terms. How does the material respond when a light ray passes through it when it's transparent? How much that light ray bends will depend on what that index of refraction number is. Now, some other software packages like RenderMan, they go a little more into the physical reality aspect, where they have this thing called extinction, which when you look up the index of refraction will also give you a number for the extinction, which basically allows the ray to behave further in a more realistic fashion. All right. For today, what we're going to do after lecture in the demo part is we are going to be adding some additional glass into the interior scene. Right now there was only one vase on the table. I've got 3 other bottles that we're going to put into the scene that are required for the rest of the usage. So today we're going to be wrapping up materials. Then tomorrow you guys are going to have an off-campus assignment. That's going to be due Wednesday. That's to make up for the hours that we lost and the instructional time, not necessarily just the hours, but instructional time that we lost during Hall of Fame. So what we're going to be doing is we're going to be taking one of the environments, either daytime or nighttime interior, or daytime, nighttime exterior. You're going to choose one of those 4. And you're going to work on that to the very end. You're going to be adding textures to it. Now, texturing is not going to be just slapping a bunch of textures in, you're done. It's going to be putting textures on, adjusting the material properties, maybe your reflectivity changes a little bit based on the materials. Maybe it's more reflective, more glossy. You're also going to be needing to adjust the lighting, because that's going to change the dynamic completely. Once you add materials and textures, your value changes in the material, and also the color changes. And that changes the way final gathering behaves. It changes the way the lighting behaves in general. Just like it would in the real world. If you were walking to a gray room, okay, you wouldn't be able to see much definition as far as the difference between this table, say, and that wall. It may look like the same shade of gray. But once you put a material on here, change the color, change the texture, then all of a sudden that wall becomes green, it's got a little more value in it. This table becomes, beige with a texture that's readable in it. Okay, Open Labs, I've got one on Wednesday from 9 to 11, and then office hours will basically be the rest of the time from 11 to 4 in my office. So if anybody needs help, come see me, especially if you're not in art. If you're in art and you need to ask a quick question, you can always go to the bathroom and run into lab, ask a question, and come back out. All right. So going to go over, before we get into our discussion on transmission today, I'm going to talk about the off-campus assignment tomorrow. Then we'll get into transmission, refraction, transparency, index of refraction, the MIA material X and how it handles it. And then don't forget the research discussion will be due Monday along with your Project 6. All right, any questions so far? All right, so the off-campus assignment, which is Lesson 7, it's for Lab Lecture 8. It's going to be worth 8 hours of attendance. Don't forget also that all your deliverables, all the projects, are worth 2 hours of integrated learning as well. So if you haven't been turning those in, you're going to be out hours. I'm going to go over what everybody's hours are today during lab. I'll call you all up one at a time. You can go over them. If you're not out any hours, great. You don't have anything to worry about. But I don't want there to be any surprises. All right, so for the deliverables section, to verify that you've done this assignment, you're basically going to be watching either last month's lecture or lecture from November. They're both the same content, except the demos are different because I demo differently based on what the class wants. Sometimes I do more demo on the outside, the exterior scene. Sometimes I do more demo on the interior. All right, there is also a PDF filled with 10 questions you need to fill out also that are based on the material that is in the lecture. So if you watch either lecture, you can watch both if you want. Either one, then you'll be able to answer these questions with absolutely no problem. Needs to be completed by Wednesday so I can get the attendance in for the registrars. We have to wrap it up before the end of class. So it is due the 22nd. While it does not contain a grade weight, it does contain 8 hours of attendance. Please don't blow it off. And also, you'll be responsible for the content in the material because we'll be talking about textures in that lecture. That's our first discussion on texturing. We're also going to be discussing something called a projection, which works a lot like a decal in a game. That allows me to slap a small logo or something specific that I want in a specific location without having it kind of baked into the texture itself. Then it allows me to move it around. For example, let's see. What could I use as an example? All right, this plate on the door at the bottom. Made of what? Metal. How's it attached? Screws. Okay. What I could do is, since in CG we wouldn't necessarily have a close-up of that too much, you wouldn't be able to see the depth of it that it were an actual plate, might be able to get away with having it be a two-dimensional picture, right? Part of a logo or part of the texture. So ideally what you would probably do is you would probably have this all as one texture initially. Either make it in Photoshop or find a door that's got the texture you want and apply it. If you do it in Photoshop, you'll have a couple of different layers. You'll have a door wood layer. You'll probably have the metal layer. You might have some other areas in here, some damage. So what usually will happen is you'll put this in, your boss will come in and go, yeah, that's nice, but they really want to have that kick plate like right here for whatever reason, because people walk on the walls, I don't know. But they always come in and say, we want to move that. So if you did it in Photoshop where you found a texture, you'd have to go into Photoshop, you'd have to physically move it into the position you want, bring your UVs in, make sure it's in the right place. If you put this in as a projection or a decal in Maya, that is on a separate layer in Maya. And that means you can move this around wherever you want because it's independent of the wood texture for the door. It sits on top of it. And that's the beauty of a decal. You can come in and you can go, we want it up here, and you can grab the layer. You can get your translate tool and you move it up, position it where you want it, and everybody's happy. So it takes a little while to get used to how projection works, because you can project something in 3D space rather than in just 2D space. And that is a big deal. Like I said, do it in games all the time. All right, so as far as what to expect, instructions here, go to the download section. There's a couple things to download. There is a PSD template for this, Lecture 8. Lecture 8 questions, PDF form. You can fill it out in either Preview or in Acrobat. Doesn't matter, it's a writable PDF file. There's an SAL logo and a Thermos logo. with the start of Project 7, which is what this is the start of, Project 7, you're going to choose one environment, right? You're going to choose either the interior day or night or the exterior day or night. One environment. That's what you're going to work on. What you're going to do is watch the lecture where I discuss basic maps, what each map contains, because that's going to be important when we get into talking about texturing. We're not only going to have a nice color map, which is going to be our diffuse, but we're probably also going to have a couple of other maps. One might be a spec map, where we control reflectivity on the surface. Another might be a bump map, which is very similar to a normal map in gaming. It allows us to get the illusion that the surface looks rough, and if we actually felt it, you would be able to feel the roughness on the surface. It's basically an illusion of what we call surface relief. It looks like the surface has been changed, but it really hasn't. So you're going to watch either the 611 lecture 8 or the 1701 from last month. Why is there no 1612? Because it happened during that crazy month we called December, and that month was compressed, and this lecture got compressed into a Sunday also. All right, so watch either 1611 or 1701. You're going to decide which environment you're going to do. If you're doing the interior environment, you will be projecting the AAA logo onto the surface. The logo is in part of the downloads. Right? I go over that in my demo. If you're going to do the exterior scene, I've got, looks like somebody, either carved it in the table or wrote it in there in pen or something. Got an SAL logo you can use and project it on there. If you want, you can go in and make your own logo, make your own initials, if you want to put them on the table. But I do need a projection on either one of these surfaces. Now, here's the caveat. If you're going to do the table outside, don't expect your wood to show through the projection label, because that involves layering in Maya. We're not going to get into layered textures until Lecture 10. That's when you can start to stack stuff and make stuff show through and look correct. This is just learning how to use a projection, learning what the maps are in a texture. Is that clear? You guys with me? Yeah. Any questions? Anybody? I want to make sure you guys are all straight. All right, so don't stress about it. You'll probably have a white box under the logo. Totally fine. Here, for the thermos, it's set up more or less so you shouldn't really see a logo box, like either a whitish box or a grayish box. If you do, again, don't stress out about it, because we will fix that when we get into layering. But make sure that it's visible. You're going to be doing a close-up shot. Doesn't have to be from the render cam. I want to be able to see the logo clearly, make sure it's not distorted, and that's a big thing about projections. Make sure it maintains the aspect ratio of your original logo. Don't stretch it, warp it, make it look distorted. Right, so you're going to render out either one of these scenes, whichever one you decide to do. That's going to be part of your deliverable in the template that I provide for you guys. So you're going to be turning in for 8 hours of attendance, render in the template, and the PDF questionnaire filled out. Okay? Any questions? All right, well, remind you again in lab too, because you guys can start this anytime you want, but it's actually for instead of coming into class tomorrow, which I figured you'd rather do it at home than come in on Sunday again and have class for 12 days straight. So, it can be done. It's not that difficult. Just take your time. And you guys will be perfectly fine. All right, all the instructions are in here. Like I said, if you have any questions, feel free to ask. All right, again, don't forget the research discussion along with Project 6 will be due on Monday. Monday before midnight. So if you haven't done so, go find yourself an article. If you find something out of the list that I have, send me a link to it. I'll take a look at it. If it looks okay, I'll give you the thumbs up and you guys can use that article for your research. Make sure you address all the talking points. I want you to relate this discussion personally to yourself. Don't just give me a recap of what the article is about. I can get that by reading the article. I want to know how it affects you. Okay, so today we're talking about transmission first because transmission occurs all the time, but we take it for granted. Great example of transmission would be light passing through air. Do we see the light as it passes through air? No. What do we see a result of when light passes through air? Well, eventually light is going to hit an object, right? And what we see is a result of light hitting an object and bouncing back to us. So we can see what it is. Tabletop, us even, to each other. That's how we relate. Transmission occurs when you have a light ray passing through a surface and it is unobstructed. It passes through directly. So, clean air would be an example. Clear glass would be another example, only if that light ray hits it at the perfect angle. That perfect angle would be perpendicular to the surface of the glass, like a surface normal. When light ray hits that glass perpendicular, it will go through it, and it will pass through undistorted or unrefracted. It's got to be really clear, because any imperfections in it could cause the light ray to bend, to warp, to reflect, or bounce off of it. So simple refraction can only occur when you've got that light ray hitting the surface at an angle perpendicular to it, just like a surface normal. Refraction occurs when that light ray is off, even slightly, of a perpendicular angle. It's called an incident angle. So once that light ray hits the surface at an incident angle, depending on what this material is, the light ray will bend slightly and then continue on once it passes through the material. How much does that light ray bend? That's going to depend on how thick the surface is. And what is that surface made of? Is it made of plastic? Is it made of water? Is it ice? Is it glass? Is it a diamond? Is it quartz? They are all going to make that light ray behave differently. Again, if it's air, it's going to pass through unobstructed, unless the air has moisture in it. Then you may see refraction. You guys have all seen in the summertime, right? Heat coming up off the ground creates kind of a wavy pattern. When you look through it, it distorts all the light rays. Usually moisture coming up off the ground. All right, so that takes us into how we get our materials to behave in this fashion. Now, we assign a material to a surface to describe how that surface will behave when light either bounces off of it or passes through it. You guys should have all modeled something similar to this in either 3DF or model creation or some basic modeling class. All right, somebody give me what would be a way to model this quickly and efficiently. NURBS curve, right? Come around, do a profile halfway, make sure it's locked onto the axis, then you do what?
Rotate around.
Yep, you do a revolve, output as polygons, right? You don't want NURBS, you want polygons. So output is polygons. Make sure that, your edges conform to the points that you put in so that it's nice and clean and even. And you have yourself a glass. You build it just like it is in the real world. So what that means is you've got an outer and an inner wall to your surface. Now the reason we have you model that is because this area in between the outer and the inner wall is what the material is describing. It's telling the light ray that's passing through it, hey, I am glass, I'm plastic, I'm wood. Not that wood is transparent, but I'm a material. So, we set this material up to behave like it would in the physical real world. We give it what's called an index of refraction number, which in the case of glass would be 1.52. That number means that when a light ray hits it, it will bend accordingly. Exit. This area in here is what? Inside the glass, what do we have?
More glass?
Is it solid?
No. Well, the glass itself is solid, but not like.
Right, so what's in here when we don't have glass?
Oh,
Air.
it's air.
Air, yeah, exactly. Air, nothing, basically. Air. So that's going to pass through fairly unobstructed. Right? Remember, transmission is going to take place here because there's really nothing for the ray to pass through. All right, it's going to hit the interior wall on the opposite side of the glass, bend again because of the material, and exit. So in effect, our single little light ray has to pass through 4 separate surfaces in CG. And that is how we track the path of the ray when it's being transmitted or refracted through a surface. Did they tell you guys how to model liquids inside bottles or glasses?
No.
No? Okay. What I used to do was model this like you normally would. NURBS curve, revolve around. You guys know about selecting faces, right? You can duplicate faces.
Yeah.
Select the interior faces. All right, so for example, if you want the glass to be half full, find the nearest face that goes up to that level. Select all the faces inside, duplicate them, scale them in ever so slightly, and then cap off the top. That way your liquid or the object that you just modeled will conform to the shape of the glass. So if you've got a vase that has all kinds of curvature, you select all those faces, scale them in ever so slightly. When you cap it off, that solid surface will have the shape of your vase without you having to remodel the whole thing. Does that make sense?
Yeah.
Now, when you cap it off, usually you put in holding edges, right? So it conforms or it keeps its shape. In the case of water, if you look really close to the edge of a glass, it has what's called tensile strength. That means there's surface tension across the top of your liquid that pulls away from the edges ever so slightly. So instead of it being perfectly planar on the edges, it's going to cave in just a little bit as that water surface stretches. That's what allows those little bugs that run across the water. They don't break the tension of that surface, and they basically skip on it because they're not in any one location too long. That makes sense. All right, so the reason I mention all this is because in the exterior scene, you've got a wine glass with liquid in it, or geometry. And that's going to have a separate material from the glass. So that liquid, whatever it happens to be, whether it's water, whether it's wine, whether it's milk, whether it's soda, it doesn't matter. We tell it what kind of material property to have, and then we assign the proper attributes to it. So, simple glass with nothing in it, our ray has to go through 4 surfaces. If we have a surface with geometry inside for liquid, how many additional surfaces is that going to add? You didn't have to keep track of this before in modeling, but you do when you're worrying about stuff being transparent and passing through it. All right, so we have our wine glass here. We've got geometry inside of it. Ever so much smaller than what the faces are that we actually modeled originally. So we've got 0.1, which is here, 0.2, which is here, 0.3, which is here. There's 4, there's 5, and there's 6. So when you have liquid inside, you've added an additional 2 surfaces to your model to calculate. Simple glass without, you've only got 4. But with liquid, since it is a solid, that liquid is considered a solid. There's no inner wall, there's no outer wall, it's not like a big bubble. That makes sense? Did I lose anybody? Just like when we had to worry about how many reflection rays did we have when we wanted to be able to see the helix inside the sphere, now we're going to worry about how many rays have to, or how many surfaces does a ray have to pass through to get to the other side. Because on the other side of this is probably more geometry. There's going to be part of your environment, there's going to be at least an image back there, so you need to be able to see through it completely. And also, you need to be able to see through for shadows. Don't forget that the MIA material X uses conservation of energy. Conservation of energy just means diffuse plus reflection plus refraction adds up to 100%. All other materials work the same way. Physical accuracy. You just basically rob from one attribute to give to the other one. So when we want to make something transparent, we're going to steal pretty much everything from the diffuse portion of the channel. We're going to steal a lot of the energy from the reflection. We don't steal it all because liquid, transparent objects still have reflectivity. Right? Good example would be this plastic bottle filled with water. You can kind of see through it, right? Transparent. You can see all the nice, cool little sparklies here. That's called caustics. When you've got light hitting a surface and it reflects in all different directions, but it's still passing through. It doesn't bounce and diffuse completely. This we're not going to worry about this month. You guys will get that later on, either in your game-specific engine or further on down the road in VSD. Because it does take a little more computing power to do, and we're not really going to be having any kind of surface that has that irregular shape to cause caustic. All right, so we can see through it, and we can also see some reflectivity. You can see speck highlight on there, right, from the light source. You can also see a little bit of the environment if you hold it the right way. Right. The refraction part of the material, The very first part is that index of refraction number. That number is a real number. If you go to any website that has a physics department, and universities that have physics departments will usually have huge tables. So this is not something that we made up just for CG. So index of refraction. You can be more specific. Of glass. Of course, if you spell it right, it helps a lot. All right, so here's a nice little table. Notice that a vacuum and air are basically index of refraction of 1.0. They're neutral. Notice you have ice, a little bit different than water. Water is roughly 1.33. Alcohol, acetone, sugary solution like alcohol, wine, for example, somewhere around 1.36, 1.38. Quartz, 1.40, which is what the MIA Material X gives you by default. Other render engines, like RenderMan, Arnold, they start off with the index of refraction for glass. Up here, what we call typical crown glass. That is standard, average, everyday production glass. 1.52 to 1.5 or 1.6, somewhere in there. 1.52 is usually the number we use. Just standard, average, clear glass that you find anywhere. Notice as the numbers get higher, they're going to be things that you recognize as being very refractive, like when you get to a diamond. Diamond, very dense. Still transparent, but so dense that when it has light that passes through it, it refracts it quite a bit. That is usually 2.4, 2.5, somewhere around there. The numbers can get higher. You can look up the index of refraction for copper, for steel, for nickel, for brass. So the internet's filled with all kinds of really cool stuff. Right? You could do all the math, or you could just look up the number. Personally, I'm a big fan of looking up the number. And yes, you can set the MIA Material X, where you can plug in a number, and eventually you'll get a metal. But there are a couple things you have to do. We're going to go over a couple more before I cut you loose. Right, so index of refraction, this describes how the ray should behave when it passes through a surface. Color. This is going to be the color of our transparent material. So if you have colored glass, you've got a brown bottle, you've got an amber bottle, you've got a slightly bluish bottle, you've got a green bottle, all right? That is all described by transparency or refraction color. Transparency, how well can you see through the object? By default, if you're making average glass, we usually turn that all the way up. And again, 0 to 1 is our limit. 1 being it's fully transparent, 100% transparent. Next is glossiness. This adjusts how the rays behave when they pass through the surface. Do they go through unobstructed, or do they get dispersed across the surface. An example of glossiness that is lowered in refraction would be something like frosted glass. You guys familiar with frosted glass? Anybody not? Don't be afraid to raise your hand if you're not. Okay. So if you're not familiar with frosted glass, this is what it looks like. All right, so frosted glass. Another example of frosted glass, sort of frosted glass, would be a glass with a very cold liquid in it on a warm day. What happens on the outside of the glass? Condensation. It behaves a lot like this. What happens? Your surface is roughed. That means it's roughed up to the point where all of the reflection rays are diffused or dispersed. All the refraction rays, the transparency rays, are diffused and dispersed. So you can sort of see through it, but it's very almost foggy looking. Right? Frosted glass can be done either chemically or it can be done with some kind of material being blasted onto the surface to rough it up. They usually use either diamond dust or sand or something. Sometimes called privacy glass. Just a word of warning, this can be expensive when you render. Just remember, anything that causes softness in mental ray or in any other material is going to take longer to process or compute. Now, you'll notice glossy samples disabled until you lower the glossiness. Glass, the glossiness should be at 1, unless you've got an example or reference for frosted glass. But like I said, it's expensive. If you're going to use frosted glass, I would recommend you keep it to just 1 bottle in the scene, because if not, it will increase your render time for everything. All right, couple examples. Very simple IBL, a plane, a sphere, and what some of the examples of changing the index of refraction looks like. Now, these are all clear. To make clear glass, you keep the refraction color white. That makes clear glass. Very simple. All right, air. Index of refraction 1.0, you can see there is no refraction. Yes, I know air does not cast a shadow, but if I didn't have a shadow there, you wouldn't believe I actually had a sphere. So just totally there so you can verify this is all the same geometry with just one thing changed. Here, index of refraction 1.33, it's water. You can see that we do get refraction, we get light rays bending. We also start to see some reflectivity. 1.52, that's glass. It distorts even more or refracts more, a little more reflectivity. A diamond, 2.42, much more refractive, much more reflective. All right, so as I mentioned, color. This is the color of your transparent material. You lower the refraction glossiness, your nice transparent bottle then takes on that hazy, frosted look. But like I said, anytime you lower the glossiness, it's going to take longer to render because you have to sample it more, throw more samples in there to clean up all that softness. So the reflections are going to soften automatically, and also the transparency. It's going to be dispersed. Now, the one thing we did not talk about in the BRDF section, the drunk friend section here, is use Fresnel reflections. I did mention that a little bit. That button allows the index of refraction to control all the reflective information. The 0-degree reflection, the 90-degree reflection, how that 0 and 90 degree fall off from each other. That's the curve. Now notice I did 2 renders. Same sphere, same environment, same lighting. Here, this is manual reflectivity with the manual BRDF. The default settings. Notice how much more reflective this is. When I turn on use Fresnel reflections here in this render, now all this information is grayed out because it is being controlled by this number. This number tells it how to reflect. And this is what you get. This is much more accurate reflective type for glass. Does that make sense? Use Fresnel reflections. The S is silent. Don't say S. It's Fresnel. If you say Fresnel, people will laugh, and you probably will not get a job. Other than they will hire you just to hear you say it wrong. And nobody will tell you about it either. They'll have you go before the board of directors, and you'll talk about Fresnel reflections, and they'll be in the back pissing their pants. All right, Fresnel reflections, French. For glass, for transparency, you want the index of refraction number to control reflectivity. That's the easiest way to get very accurate glass. Now, is it 100% bulletproof? No. Anything with Maya? No, nothing is 100%. However, what you can do artistically, there are certain types of glass that look very reflective, that have got a coating on them. And that coating makes it look more metallic or more reflective. In that case, you would turn that off and probably go with manual reflectivity for the BRDF section. Now, as far as the reflection section in the material, the standard reflectivity you get in a material is usually suitable for glass. Bless you. So, are we done? No, because we have to go into the render settings. Just like we did with reflections, in order to get chrome, in order to get a mirror, you had to make sure there were enough reflection rays. Same thing with glass. Transparency. You have to make sure there are enough transparency, or they call it transmission rays. So we have to crank them up. Usually, the average by default is 4, 4, and then this number at the bottom, the max trace depth is 8. We went over that, right? It's always, that max trace depth number is always reflections plus transmission. Now, for an average bottle, an average glass, 4 transmission rays is usually adequate. But there are times when that's not going to be enough. For example, if I've got liquid in my glass, how many surfaces does my ray have to go through? 6. There are additional things to worry about. This bottle right here on the right side, the red bottle, that is called a Klein bottle. That Klein bottle is very unique. The Klein bottle actually fills from the bottom of the surface, down under here. So liquid goes in, comes around the neck, and then dumps into the bottle itself. That means that this bottle has an interior neck that goes through it. Why? Good question.
How is that functioning either why?
Well, it started off as a mathematical enigma. They knew that this shape was possible in the physical world, but before modern production methods, a traditional glass blower could not make this. You guys know about traditional glass blowing, right? You get a big molten blob of glass, you put it on the end of a long tube, and you blow on it, and you shape it with tools till you get the shape you want. There's no way you could get the neck of a bottle to go through itself and out the other end if you're a glass blower. It's just impossible to maintain the integrity of the neck of the bottle as it passed through another set of molten sides. Now, when we finally came up with injection molding or molds that we could then force material into, this became possible. They use this all the time in scientific research, this bottle. You can also buy them on the internet. They make them in plastic. They're about $5, $6, $7. Makes a great conversation piece. Also makes a great party toy too, because you can fill this up. And like I said, the liquid goes in, fills up here, and then you give it to the guests and they try and get it out. You can't get it out until they make special bendy straws that you can then bend in and then have your beverage. But so Klein bottle, you look them up on the internet, they're there. This has an extra 4 surfaces in it. Why? Because you've got the outer surface, the inner surface, outer surface. You've also got the neck, which contains the same geometry. You've got an outer surface, inner surface. There's a hollow center. Then you have the inner surface, outer surface, and it passes through. So this 4, and this is 4 also. So in your render settings, you need to set it up for the worst case scenario. That would be 8. So if we change transmission to 8, what's it going to make the max trace step? 12, yes. Remember, it's always reflection plus transmission. Just like with reflectivity, are we done there? No. We have to go to shadows and plug the same number in, because you're going to want to see shadows through those 8 surfaces, or have your array at least pass through so it doesn't create a shadow. Because remember, if you don't have enough shadow rays, your surface or your array will stop calculating shadows right when it hits the interior, and everything after that will be shadowed. It will not continue through. Are we done there? No. Put away that checkbook. If you order now and no additional cost, you also get to do each light. Don't forget, ray depth limit. That's so that the light broadcasts enough shadow rays. So we have 2 settings. Render settings, that's global for your entire scene. Then you have local settings, which are either going to be material or they're going to be a light. So what number would we plug in here? For glass, 12, same number. Remember, once you figure out that max trace depth number under trace depth, that's your number that you follow through for shadows and for ray depth limit. Okay, does that make sense? Today we're talking about transparency. So, here's a little cheat sheet for you on making glass. It's also a download in the practice part of Project 6. We'll go into Lesson 6, practice. Down at the bottom, there's a JPEG of this. I think it's a JPEG. You can download it. If you follow these steps in the order that they're in. That will get you a good start. Now, after a while, after you've done this enough, you pretty much know what you have to do. It's like anything. You practice it enough times, you remember it, you might take shortcuts somewhere, as long as you don't leave any steps out. So, just like with any reflective materials, first thing you want to do is assign a new material to your geometry. Change the index of refraction. If we're making glass, it's going to be 1.52. Transparency, if it's average glass, we're going to make it 100% transparent. Then you're going to change the color. If you're making clear glass, white is fine. If you're making colored glass, you need to find the color for the glass you're going to use. That means finding reference. I like that color bottle. I want to use that in my scene. Just make sure when you find reference that it's in an environment similar to yours. If you're making dark glass, the process is a little different. And I'll explain that I'll explain that in more detail when we actually do the demo, because it'll make sense to see it rather than just talk about it. You want to make sure you turn on Use Fresnel reflections under the BRDF section. That way all the reflectivity is handled by the index of refraction. Render. At this point you want to render, make sure you're on the right track. Then you go into your global settings. That's the render settings. Check your trace depth. Go into legacy options, plug your shadows in. Then go into your lights. However many lights you have in the scene, plug in your max trace depth number under ray depth limit. Render. The last step that you're going to do for glass to finalize it is in the material under advanced reflections. There's a little switch called skip reflection on inside. You want to turn that off. Uncheck it. Because you want the glass to be reflective inside. It means light's going to bounce around, reflections are going to bounce around. It's going to look a little more alive and not dead. And that's usually one of the main drawbacks of early CG was we weren't seeing reflections inside the object. And it looked okay on the outside, but inside it looked flat. Some game engines still have trouble handling this. Refractions and glass are pretty labor intensive because most game engines are busy handling collisions, they're handling visual effects, explosions, fires, all kinds of different things are going on. Animation's going on at the same time, dynamic lighting in some cases. So there's a lot to do. All right, now, like I said, you're going to download the Lecture7 Maya scene. That contains 3 additional bottles that you guys are going to put into the interior scene. If you import them, they are correctly sized and correctly positioned. They will drop right in your environment. All right, so let me fire up Maya. Okay, I'm going to open up the interior scene. Oh, wrong interior. That's the exterior. All right, so here's my interior with some textures thrown on it, or materials, sorry. Anybody figure out how to turn off the wireframe unshaded in here? Does that drive anybody crazy? Good, it didn't drive anybody crazy? Usually there's at least one or two people that just irritates. Okay. Basically, you want to go into the attribute editor under the shape node. You guys know about shape nodes, right? In modeling? Shape nodes are what describe your model in 3D space. Go down under Object Display. And let's see, where is that at? Maybe it's under Smooth Mesh. It's under Smooth Mesh. That's what it is. Under Smooth Mesh. So notice that it says Smooth Mesh Display Cage plus Smooth Geometry. We want to turn off the cage. So when you have cage turned on, you deselect it, you see the cage, which is basically your mesh. You want to just turn on smooth mesh. You do the same thing for the chair. So now when it's deselected, it doesn't show up with wireframe on shaded. All right, now, first thing I'm going to do is import the bottles that I've set up for you guys. So hopefully everybody knows how to import objects. It's not that difficult. If you want to go to import options, reset them just in case. Take my bottles and import them. They will drop in exactly where they need to be in the scene. Everybody see that? Yep, all you have to do is import them. Save as, because now this is going to be a different environment. This is required for turn-in for Project 6. Because we want to have the additional glass in there. All right, first thing we're going to do is work on the vase. So for the vase, you want to assign a new material to it. We'll go down the checklist in order. What's a shortcut to assign new material? Shift T, thank you. Material, MIA Material X. Go under the material. It's always a good idea to rename it. Vase. What's next in the JPEG? Okay. What's the next step? We assigned a new material. What's next on the list? On the JPEG. Bring what in? Well, we're making glass. We're making clear glass. Yep, index of refraction to 1.52, thank you. Right. How do I know that's what we're doing? Because right here in the directions under milestone 7, it says the vase will be clear glass. The vase will be clear glass, but the hourglass, the rectangle bottle, and the Klein bottle are all going to be different colored glass. So we're working on the clear one first because that's easy to get. All right, so we have 1.52 in there. All right, so that is part of what we need. So what's next? Yes? 1.0, good. So you notice, by default, that's not too bad. I mean, it's clear, it's reflective, sort of refractive. You can see the back part of the table doesn't quite line up with the outer part. Now, at this point, I'm using IPR, which I don't believe. I think it lies. So I'm just going to do a render region just to verify. And it does look slightly different. Not too bad. So you can see here, the edges, they kind of don't line up, which says, hey, we've got some refraction there. So, not bad. I mean, right out of the box, all we did was change 3 things. We put a new material on it, we changed the index of refraction, we made it transparent. What's next in the list? Yeah. Okay, so in this case, we're clear, so we're going to leave it white. So that part's good. That check part's done. What's next? Yeah. What was it? Leave off the S. The S is silent. Fresnel. Yeah. Yep, very good. So down here, BRDF section, turn on use Fresnel reflections. Notice it grays out that whole area. That means our index of refraction is now driving how reflective that surface is. Notice it's not that reflective now. Not as much. And you might say, wow, that looks a little better. Well, when we get done with this, no, it's not going to look better. It's going to look more realistic. Okay, good. That part's done. What's next? Yes?
Change the refraction color to glass color.
We already did that.
Oh, the white to the.
It's white by default. And we did the Fresnel reflections. Who said render settings? Yes, absolutely right. So at this point, we want to go into render settings, and what do we want to check first? Yeah, let's go to trace depth. By default, it's set for 448. That's not bad. That'll give us probably enough reflectivity that we need, even for self-reflecting surfaces. And that'll give us enough transmission rays for this surface. All right, so we verified that that is correct. Now, at this point, I want to pause for a second and show you something that may or may not happen to you in your environment. Who here has a table that's lighter than mine in color? Okay, so anybody with a lighter looking table, this is what's going to happen. So let me take my material, lighten it up quite a bit. So at this point, most of you with a light table will have this problem. Notice it looks like it's the surface of the sun back here, but yet that table is not nearly that bright. This is caused by what we're going to solve in the next part. And that's in the render settings. So we did our trace depth. What's next now? Yeah. Yep, legacy options for shadows. What do we plug in there? Yep, same number as trace depth, so that's 8. So you say, okay, good, yay, done, fixed. Maya says no. What's the next step? What is it? Go to your lights. All right, so I got 2 lights in there. Got a directional light for the sun. I got an area light for the window. What do I do to them? All right, go to shadows. Ray depth limit, what am I plugging in? Yep, 8. And I have to do the same thing for the other light, the area light. Now, when I render that out, I'm allowing all my rays to get through it completely. That is a whole world of difference from what we had before. Now our lights are broadcasting enough ray information for shadows. Our global settings are high enough to be able to accept all of the extra ray information. Right, one more thing we want to do to this. What's the last thing on the hit list? Yeah. Okay, how do I find that? All right, and that's in the material itself. So I go into the material, I go under reflection, I go down and I expand advanced reflection. There's a little switch down here that says skip reflection on inside. I want to turn that off. Keep my image and re-render. Now that should allow reflectivity to bounce around inside. That should also get rid of some of the dark edges on my glass. That should look a lot more like an actual glass vase than the previous version. Right? I have really low settings, so it is going to look noisy. So you definitely want to turn off skip reflections on the inside. All right. Did that make sense to everybody? If you follow the checklist, it's usually going to get you 90 to 95% of the way there. Now, the other part is going to be what happens when I have colored glass. And that's what we're going to work on next. So, somebody pick out a bottle. Which one? Which one?
Square one.
This one right here? Square? Okay. We'll do that one. All right, let's take a look at it close up. Extreme close up. I'm going to go to wireframe. And what we're going to do is take a look to see if this has any special hidden geometry anywhere that might cause us an issue. All right, you can see inner and outer surface, pretty unobstructed. Looks like a standard, like old-timey medicine bottle almost. I don't know, maybe a Jaeger bottle or something. All right, so nothing hidden anywhere there. While we're in wireframe, let's take a look at the other two bottles. So we've already verified the Klein bottle here. Right? It's got that extra geometry inside. How about the hourglass bottle? Does this have any kind of special shape to it? What's it have? Okay, it bends in, but at any point is it going to cause my ray to hit additional surfaces? Probably not. There on the body. But here's where you may get fooled. Look at the cap. That cap has a mushroom lid on it, or it kind of overlaps on itself. So right there, how many surfaces does our ray have to go through now? So you got an outer, an inner, an outer, an inner, inner, outer, inner, outer. 8. So this deceptively simple looking shape has actually 8 surfaces for a ray to go through. So it's very similar to the Klein bottle, not as complex, because a glass blower could make this easily. You know, while the glass was still molten on the top, they could just put a tool in there and shape it so it mushroomed. Okay, good job. All right, so we're going to go back and we are going to start to make some glass, different colors. First thing you want to do is find reference for the color you want to do. Can't stress that part enough because so many people get tricked up trying to make glass from memory when that's why you got the internet. You don't have to rely on your memory. All right, so if you type in colored glass, you're going to come up with all kinds of stuff for stained glass windows. You might have a few bottles in there. You're going to see a lot of artsy-fartsy stuff. What we want are colored glass bottles. All right, now normally, I would say to you, you want to make sure you find glass or you find your reference in an environment similar to what you have. Yes, you want to do that. However, if you're trying to get a good sample of color, a lot of times you may want to have a white background because you can get a purer sample. You guys remember what happened when you tried to sample the interior or the exterior for color for the light? You wound up either getting a lot of green or you got a lot of value in your color that made it really dark. Here, if you sample here in this image, you're going to get a lot of value in there. What we're trying to do is find something neutral. And this image, while it's not perfect, it doesn't show an environment, it does show a decent example of color for glass and how it should look if it's got decent lighting. This is a good image for an interior. So what you may want to do is have a couple of them. Take this one for color, use this one for how it's going to look when it's in an environment. Because your colors are not going to be that pure or that saturated. They're going to look a lot more like this. Does that make sense? Okay. All right, so I'm going to download this one just to have for reference. Actually, I want to go to the website. Going to save my image. And I'm going to use this one for my actual color picker. So how can you go wrong when it says awesome colored glass bottles? Somebody's not muted. Now you're muted. All right, so we have our reference. All right, so let's go in order. So we're going to do the rectangle bottle. What's the first step? New material. Good. That means MIA material X. Going to call this rectangle bottle. Okay, what's next? Yep, index of refraction, 1.52. Done. Transparency to 1. Good. Are we going in order, though? Doesn't matter as long as you get all the steps, but it's always a good idea. Color, yeah. So color, this is where we need our reference. So I put my reference on the desktop. Going to keep image. What color should we make the rectangle bottle? All right, I heard green and red. Who wants green? Who wants red? It's a tie. Looks like green just slightly edges out red. All right, so we'll call this one green, even though that one's kind of a yellowish greenish. All right, so this is going to be our color. Best way to get the color from my render view into my material is how?
Color, use the pen.
Yeah, eyedropper.
Yeah, eyedropper.
Yeah, so we're going to the refraction color. Take my eyedropper, and I'm going to find a relatively pure area for the color. I don't necessarily want to go too light. I'm going to pick an average area like right here. All right, so I color picked. Looks fairly similar. Should, I mean, I picked the color right off the image. Now what? What's next on the famous list? Okay, BRDF. We want to turn on use Fresnel reflection. All right, now what? Well, I'm going to go ahead and render it. Okay, it looks a little dark. All right, do I need to worry about my render settings? I do? No, because we already did them for the previous bottle. So those are a one-shot deal. Render settings, lights, they're done already. So that's less that we have to worry about. Good. All right, so we want to go back to the material. Right, so advanced reflection, which makes sure it's REFL, reflection, skip reflections on the inside, keep image, re-render that, take a look at it. Notice it takes longer and longer to render, yes. Which step?
It was the one that you did just pre-rendered.
Oh, that's turn off skip reflections on the inside. That's the last step in the JPEG. Because we already did all the render settings already for the previous bottle. So the render settings and all the lights are done. That's a one-shot deal that you do. Does that make sense? All right. So yes, that did help a little bit. Notice we don't have dark edges on our bottle anymore. That looks a little more natural. Now, here's something that you want to check because we're doing colored glass. And what you want to check is the refraction, color, hue, saturation, and value. You just click on it, bring up the simple color picker. Here's what happens. Notice that my saturation is pretty high. For glass, we usually like to keep it lower, but dark glass, high saturation is okay. Because you want really deep, rich looking green. Notice the value. My value is set to what? Yeah, 0.776, 0.75-ish, 0.78. Anytime your value falls below 1, you are actually taking some color from the diffuse part of the material. Because when your value goes below 1, your transparency gets lowered also. Because the glass color is no longer white with a value of 1 letting all transparency through, once you lower it, we're pulling some color in from the diffuse. How do I know that? Because we're seeing it look unnaturally dark compared to our sample swatch here because we're getting some of that color, and the diffuse default color is what? Gray. So if I turn that white, it still looks, it starts to look milky, is basically what happens. So anytime you've got a value in your color, your refraction color below 1, you're pulling additional color from the diffuse part of the material. It's all part of that conservation of energy, right? So it's not 100% transparent now. Some of it's coming from the diffuse. So what we have to do is we want to put that same color in the diffuse. Except for the diffuse, we don't want to make it more lime. We want to make it a nice deep rich color. So we lower the value and turn up the saturation a little bit. And any additional color that comes in from the diffuse is going to be the same color as your glass, and it's going to make the color look deeper and richer. So making dark glass is kind of a two-part process with color. You get your primary color in the refraction. If your value in your refraction color is below 1, you're pulling additional color from the diffuse. Unless you change that, you're going to get that milky looking diffuse color. Now the problem is with a deep rich color like this, I really don't need all that value in there. So let me hit escape. So what I can do here in my refraction color is lower my saturation a little. I'm going to increase my value a little so it pulls in less color from the diffuse. So usually when you have dark glass, your refraction color has the value close to 1, the saturation lowered, usually below 0.5. Your diffuse color is usually the same color except your value is lower, it's deeper, and your saturation is higher. So now it looks a little more transparent, because we're taking less color from the diffuse. Does that make sense? You can do this same technique for the exterior scene, for the wine bottle. The wine bottle needs to be somewhat transparent. It's going to be empty. So we should be, no matter how dark it is, we still should be able to see through it because it's a bright sunny day, sunlight's going to be coming through it. We don't want images where the bottle's totally reflective or it's filled with liquid. That's not going to work. It's supposed to be an empty bottle. Right, you want to do another one? Or do you want to do the exterior? All right, do the exterior. All right, so since this has materials on it, I've already got base materials assigned to my bottle with just color on it. My glass I just left alone. So let me save this out so I have a version of it. And for this, I can pretty much go right to the render cam. All right, so for the wine glass, this should be pretty simple. You guys should be old hands at this by now. Turn down my quality, which is unmercifully high. All right, so for the wine glass, that's going to be transparent, simple. What color is transparent glass? White. Yep. All right, so I've already got a material assigned to it because this is all part of my materials exercise. So what do I do next once a material is assigned to my geometry? So index of refraction, 1.52, right? The color's already set. It's clear. We're doing white. Yep, transparency all the way up. Good. Next. Color's going to be white, so it's clear glass. Yep, so under BRDF, use Fresnel reflections. We're turning that on. All right, so I get a transparent object. Sort of glassy looking. It's got some unidentified liquid inside of it, which we'll worry about later. What's next? What do I have to worry about? What is it? Yes, render settings. This is a brand new scene. We didn't do anything to this. So render settings, trace depth. Woo, that one's off. So reflectivity, what can I get away with? What's that? Anybody? Yeah, we can get away with 4, maybe 5 if we need it. We can try 4 to start. That's good. How about transmission? Now, we have a wine glass. We also have geometry in the wine glass for the liquid. So our ray goes through how many surfaces? 6. So our transmission has to be 6. We set it up for the worst case scenario. What does that turn our trace depth to, our max trace depth? 10, right. So now what else? No, we're not quite done yet in the render settings. There's one more thing we have to check. Shadows, that's under legacy options. So we plug in the same number for shadows. Now we go into our light. Okay, we got our directional light. Ray depth limit. Crank that up to 10. Going to do another render. Should go pretty quick. All right, so that now has enough refraction rays in it. You can see the difference. Okay, what's left? Yep, turn off reflections on the inside. Skip it. Where's it at? Yep. Advanced reflections in the material. Advanced reflections, skip reflections on the inside. All right, we got a lot of sunlight hitting it, so it is going to look a lot more alive. All right, that takes care of it for now. Next, we're going to do the geometry in the glass, the wine. Notice we have a solid surface here. All right, we're going to choose wine. What should we use for an index of refraction for wine? If you're not sure, look it up on the internet. They got some weird stuff on that interwebs. So we're looking for, what color wine should we make? Purple. What do you need? Okay. Yes. 1.33 is water. So that's why we want to figure out, well, first off, so you want purple wine. Purple wine in glass. Let's be specific. That is artificial. Yeah, it's mostly purple glass with wine in it. All right. Yeah, I like that idea better. All right, so let's go with red wine. It's either, your wine is probably either going to be white, red, or Zinfandel, which is pink. All right, so you pretty much have three choices. There are different color wines, but you need reference for it. It's got to be real. You have to be able to see through it a little bit. It can't look like a black hole inside a glass. All right, so let's look for red wine in glass. And let's look for it outside. Because we are outside. All right, so there's a decent one. There's one there. That one. That looks like an overcast day. I wouldn't drink anything that looked like that. If you can't see through it a little bit, it's probably too cloudy. It should have a little bit of sparkle to it. depending on how much light you have, will be, let's get a decent size. Let's get a nice large look here. All right, this one will work. Can see through it. That'll be my reference. It is quite a large image. Now, we see it's dark because it's behind, looks like a lot of green. We're seeing the inversion of the trees and the environment it was in. All right, I'm going to save this out to my desktop. That's going to be my reference. So we've decided on red wine. Now let's find out the index of refraction. And I want to go to all. I don't want images of it. All right, here we go. Difference between red wine and white wine. So first result, I'll take it. Ooh, guys in lab coats. Must be good. All right, so anytime you get to a website, first thing you want to look at is, does it look legitimate? Most wineries have little areas where they test their wine for sugar content, for alcohol content, ethanol versus whatever else is in there. You want to go down and look for the different indexes that they'll have. They'll have charts similar to this. All right, that does me no good. I have no idea what they're talking about, nor do I care. I get into here and I see, ooh, names. Red, white, but I don't see any index of refraction. All I see is the white has 12% alcohol. So I go down further, go down further. Ah, this is what we want right here. There's your index of refraction. And yes, you were right. 1.33 is very close. However, our index of refraction, we have 3 decimal places. And believe it or not, that third decimal place makes it just a little bit different than water. And if you're going to go this far to be accurate, you may as well go that extra decimal point. So I understand what you're saying, yeah. If you were rounding it off to 2 decimals, you could. And actually, you can plug in 4 numbers, and Maya won't display the 4th number, but it will keep it in memory. So we have to decide which one we want. It looks like red wine goes anywhere from 1.3390, 1.3394, even down to 1.3375. So it's a pretty broad range, it looks like. So at this point, you have to pick a number. So which one should we pick? Does it matter? Probably not. It's red wine. You've got the reference here. So maybe pick 1.3390. So, first thing we have to do is assign geometry or assign a material to that geometry, because by default that's going to have that diffuse material on it, unless you assigned a material to it in your materials exercise. All right, so Shift T, same MIA material X we assigned to everybody. This is going to be called wine. Done. Next step. You treat it just like you would glass. So, we've already assigned a new material to it. Next, we assign index of refraction. What did we decide we were going to do? Yep, 0.3390. Lowers it a little bit. Why not be as accurate as possible? If you're trying to make something look good, go the extra step. All right, next. Transparency, yep. It's probably going to be transparent. Some of that transparency is going to be adjusted when we get the color. So at this point, we want color. We also want to get our color from the reference image. So I'm going to go in here, load in my reference. I'm going to keep my image. And at this point, I can now sample my color right from the image. So refraction color, color picker. I'm going to go down to an area where I can see sky, where it's going to give me a little purer color rather than here. That's going to be really dark. So right there. Now immediately you can see it looks milky in the sample swatch. That means we're getting additional color from the diffuse. But I'm not going to adjust that just yet. I want to go through the rest of the steps first. Then we'll go back in and we'll tweak the color. So what's next after that? So we've got the index of refraction, we've got the color, we've got the transparency. It's a word nobody wants to say. Fresnel reflections, yes, thank you. Don't be afraid of it. Okay, use Fresnel reflections. Do we need to go in and worry about render settings? No, we already did that. We did that for the glass. We set it up to include the geometry for the wine inside. Bless you. All right, let's render it out, see where we're at so far. Notice that it's not perfect, but I am getting a transparent shadow, the color of my wine. And that's what we want to make sure we get. That lets you know all your render settings seem to be working okay. Got enough transparency, got enough shadow rays. It's picking up the color because the rays are passing through the liquid, through the transparent geometries, onto the table. Now, it's not too bad as far as color goes at this point. Really not as rich, though, as what we have here. So, for this, we're going to go up and we're going to take a look at what's going on in our color. So, we know we're getting a little bit of milky gray from the diffuse because our value is below 1. Saturation's high, that's not bad because this wine color is going to be pretty saturated. It's not like a white wine where it's kind of yellowy and it's clear mostly. All right, so what we're going to do is go up to the diffuse color and we're going to plug in the same color that we have in the refraction. Right, so that's in my color picker. Here's the difference though. Notice it looks really vibrant and it almost makes it look glowing. Right, what we're going to do is I'm going to turn down the value because I want any color coming from the diffuse to be rich and deep. I'm actually going to turn up my saturation all the way. So now if I pull any color in, it's going to be a deep, rich red. It's going to get rid of that little bit of milky color that we see with the diffuse in there. All right, so you can see with that little bit of milky in there, you get some of that milk in your reflectivity. That is going to look closer to our wine than up here. Right, does that make sense? Any questions? All right, one last thing I want to do is I want to go back into the interior scene and I want to show you something about the Klein bottle that you're going to have to be aware of. Whatever we do to the Klein bottle, we're also going to have to do to the hourglass because it's got that same mushroom cap on it. All right, before I close out the exterior, any questions? All right, so the Klein bottle. I'm going to pull all the other bottles out of my field of view because I don't want to have to worry about rendering them in addition to the Klein bottle. All right, now, I'm going to demonstrate this with clear glass only because it's easier to see if it's clear than it is if I put a color on it. But you guys know the Klein bottle has to be a color. All right, it's in the directions. All right, so first thing I want to do, I'm going to assign a new material to the Klein bottle. Index of refraction, 1.52. Pretty simple. Going to keep the color clear. Transparency at 1. Use Fresnel reflection. Skip reflections on the inside. All the easy stuff that you would do for clear glass. Now what I want to do is render this out and see what it looks like. So it doesn't look too bad. I mean, I can see I've got a neck inside the bottle. However, something that may not be too apparent to you is you have a little bit of trouble seeing through on that neck. Let me swing this around a little, make it easier. Notice on the bottle I can see the reflection of the rectangular bottle next to it. So I know my reflectivity is working. I know everything else seems to be working in the scene. All right, so the one thing that I'm having trouble seeing right here, and it's going to be hard to see unless you look on Go to Training here, I can't really see through the neck of the bottle to see the line that separates the body from that interior neck. Right back here. Right? All my transparency is used up. So what I need to do is go into my render settings, take a look, check everything out. All right. My Klein bottle, how many surfaces does the ray have to go through? How many? 8 surfaces, yes. What are my current settings? 4. So I need to crank that up to 8. That means 12, yes. Big number. So now I have to do the same thing to what? I have to go to shadows. Don't forget shadows. Then I have to go to lights. $12. Everybody's happy. Keep image. Re-render that. This is the same issue you're going to have with that hourglass. Notice it is going to take longer to render. You thought rendering took a while before? Glass, metal, expect several minute renders. Final render on this could be in the teens. Right, so a little bit better, sort of. You can see the inside, but now we have another issue. One that's hidden from you. And that is the material itself. The MIA Material X, by default, limits the number of rays that can affect reflectivity and refraction. That number is set up to be 5 because 5 is a decent number for reflections, 5 is a decent number for transparency or refractions. What's happening is our material is no longer accepting any more refraction rays past 5. How do I know that? If you go under advanced refraction, that part's going to be right above anisotropy. You'll see that it has a number here called max trace depth. That is the total number of refraction rays that the material is accepting. And it is set up to be 5. All MIA Material X materials are set up to be that way. That's a way you can make them efficient. If you've got big numbers globally, you set the material up only to take what it needs. That way it doesn't spend time calculating something it doesn't care about. But in this case, we need to change this number to what? You would think. But this trace depth number, unfortunately, does not mean the same thing it does in the render settings. This is the total number of rays for refraction. So what we have to look at is what did we turn our refractions or our transmission rays up to in the render settings? 8. So that's where we have to plug 8 in here. Plug in 8. Now the material is going to take the rest of the refraction rays and use them. So now when I render this out, I should be able to see through that interior neck to the other side. Right now it's acting like a mirror after 5 rays. So now you can see the other side of where the interior neck connects to the body. And yes, it will take longer to render. All right, so you can see there's the difference. It's acting like a mirror because it's ignoring anything past 5. Now it's allowing everything to go through. This same process is what you're going to have to do to the hourglass bottle on the end table to make sure it's got enough refraction rays or transmission rays. Okay, any questions? All right, go to lunch. We ran a little bit over, so come back at noon.